right, guys, you guys had some great thoughts on what you felt made the ball not fall to the ground. Some of you said that it was your muscles. Your muscles kept it from going, that you threw it strong enough and hard enough that it didn't fall to the ground. You guys all had some great thoughts, and now what we're going to do is we're going to take what you guys thought and we're going to see if according to our article your thoughts are correct. If you guys have any questions, how about if you wait until the end and we will answer all questions at the end. But we're going to start with this article, Forces on a Baseball. And what we're going to do is I'm going to start reading, and then if you guys want to volunteer, we will just pass the paper around and you guys can each take a turn. If nobody wants to take a turn, some of us will read a little bit more than others, but we're going to go ahead and read this, and then we're going to see how many of our thoughts were right on what affects that ball that we throw or push. So, a force is a push or pull on an object. Forces can make things speed up, slow down, or stay in place. So do you guys ever notice that when you roll a ball down a hill, it goes faster than if you just roll it across a straight surface? As it gets further down the hill, it goes faster and faster and faster. That's what they're talking about. Forces measure two things, direction and strength. So when you let go of a ball, you put some force behind it, and that force that you put behind it affects where it goes and how fast it goes. To describe a force, we need to know both of those things. Those are both very important for figuring out what the force is on the ball and how fast it's going to go and the direction it's going to go in. When a baseball flies through the air, it meets three kinds of forces. These forces are called weight, drag, and lift. So in the next page, we're going to learn a little bit about weight, drag, and lift and how those work, what they are, how they affect the ball. So who would like to take a turn now? Okay, Blaine, you want an opportunity? Why don't you read the first part of weight? And then Liam, you want to read next, so you can read the next part. And Liam D, you want to read the final part. That will work perfectly. And then we'll go on to drag. All right, thank you guys for taking care of reading the weight part of the article for us. Now, who would like to read the drag? We have two separate sections. So do we have two little girls that might want to come up here and take a spin at reading these? Okay, Finley, you want to come up and read the beginning? And Riley, you can take the end. Okay. All right, thank you two for taking the opportunity to read drag. Now we have lift. And lift is 4 sections. Do I have any more volunteers? Anybody? Okay, I'll go ahead and read it. Lift is a force that points upwards. So when we say upwards, which direction is that? Very good, up. So upwards. The weight force pulls an object down. Lift acts against the weight force. It pulls the object back up. Like drag, the lift force is affected by the size, shape, and speed of the object. Weather also affects the lift force. The lift force acts on the whole baseball. However, we can imagine that it is focused on one point. This point is called the center of pressure. It is an imaginary point like the center of gravity. If a baseball was perfectly round and smooth, the center of pressure would be right in the middle. A baseball is not perfectly round, though. What makes a baseball not perfectly round? Is there something, because when you think of a ball, you think it's perfectly round, but what affects the shape of a baseball? Does anyone have any guesses? Darian? You think the laces? I think you're right. Let's find out. If a baseball was perfectly round and smooth, the center of pressure would be right in the middle. A baseball is not perfectly round, though. It has stitches on it. So you're right. The laces are also called stitches. So it's not perfectly smooth either. As a result, the center of pressure moves when the ball is in the air. This causes the ball to dance in midair. It's what makes a knuckleball so hard to hit. So, you guys were pretty accurate on your thoughts that the strength that you put behind the ball can affect the direction it goes and how fast it goes, and that's what keeps it from dropping to the ground. If you just take a ball and let it go and not put any speed or force behind it, it's just going to drop to the ground, and that is part of gravity that just pulls it straight down. And we talked about that a few weeks ago and learned how, you know, it automatically, if we let something go, it's going to go to the ground because that's the center. So you guys, do you have any questions? Do you have anything that you want to talk about in regards to the article? I know some of you play baseball, so you're familiar with the stitches in it and how when you hold the ball, it's not perfectly round because it has some uneven areas where the stitches are at. So, does anyone have any questions? Okay. How about I'm going to put a few vocabulary words on the board, and I think we'll probably put lift, drag, and weight, and then we will write down the definitions to those in our writing notebooks, along with your answer to the writing prompt that we had to begin with. And then we'll head to lunch, and then right after lunch, you guys will come back and you'll do your science experiment to show the force and the speed and the direction that goes along with playing tug of war. So go ahead back to your seats. We will write those words up on the board, and we will work together to write the definitions in our writing notebooks.